The night sky, with its serene and mystical beauty, has always captivated stargazers. But among the twinkle of billions of stars, have you ever wondered, why is the night sky dark? If there are countless stars in the universe, why doesn't their light illuminate the entire sky like during the day? This seemingly simple question puzzled scientists for centuries, and its answer reveals much about the nature of the universe. In fact, if the universe were infinite and filled with stars, then no matter which direction you looked, you should see a star. So why isn't everything glowing brightly at night? This question was posed in the 19th century by astronomer Heinrich Olbers, and since then, it has been known as Olbers' Paradox. To understand this paradox, we first need to grasp the nature of the universe. Contrary to the initial belief that the universe is infinite and eternal, scientists have now determined that the universe has a finite age, around 13.8 billion years. It all began with the Big Bang, an immense explosion that created space, time, matter, and energy. Since the speed of light is finite, about 300,000 kilometers per second, we can only see light from celestial objects within the distance that light has traveled to Earth over the entire history of the universe. Light from more distant stars and galaxies has not yet reached us, so we only observe a small portion of the universe, called the observable universe. Stars that are too far away or too young in the universe's history haven't emitted enough light for us to see yet. But that's not the only reason. The universe is also expanding. This means the distance between galaxies is increasing. As space expands, the light from celestial bodies is stretched, leading to a phenomenon called redshift. Light that originally came from stars in the visible spectrum gets stretched into the infrared spectrum, or even beyond, into the microwave range. As a result, this light becomes invisible to the naked eye. Additionally, not all stars in the universe exist forever. Stars have a lifespan. They are born, live, and eventually die. As stars age, they transform into white dwarfs, neutron stars, or black holes. Black holes, despite their massive size, do not emit light, making them invisible and unable to illuminate the night sky. Moreover, there are vast clouds of dust and gas in space that absorb light and obscure our view. There are also regions of the universe completely devoid of stars. These areas contain only dark matter, a mysterious form of matter that neither emits nor interacts with light as we know it. Dark matter accounts for about 85% of the universe's mass, yet it is entirely invisible to the naked eye and even to modern astronomical instruments. Thus, Olbers' paradox is not merely a question about light and darkness, but also reveals important characteristics about the nature of the universe. It helps us understand that the universe is not infinite in age and is not uniform everywhere. The expansion of space and redshift prevent light from distant stars from reaching us, and dark matter renders many parts of the universe completely dark. In fact, the light from the Big Bang still exists in the form of the cosmic microwave background (CMB) radiation. This is the oldest radiation we can observe, providing direct evidence of the universe's origin. However, because it has been redshifted so much, the CMB is invisible to the naked eye and can only be detected through sensitive measuring instruments. An interesting question is, will the night always remain dark? In the distant future, billions of years from now, as stars gradually exhaust their fuel and stop shining, the night sky will turn completely black. Stars will fade away, leaving only black holes and white dwarfs. The universe may become a cold and dark space, filled only with the remnants of massive, yet invisible objects. This is the scenario of the so-called cold universe, or heat death, where the temperature of the universe gradually reaches its lowest possible point, and no sources of energy remain to produce light. Why is the night dark? It's a result of the universe's finite age, its constant expansion, and the redshift of light. Even though there are billions of stars in the universe, we can only see a small portion of their light. In the distant future, the night may become completely dark as stars gradually disappear. The night sky is a gateway to countless mysteries of the universe. Not just darkness, but a place that holds unanswered questions.